Hello everyone, Shahid here. This video is the continuation of my previous video regarding controller. A link of my previous video also I have given in the description. So this video we talk about the controllers in details. Okay, we'll start with the first controller, that is a replica set controller. So what is the replica set controller? In simple definition, it's a controller that ensures a specific number of identical pods are always running in the system. Let's say you have created a replica set with three replicas, then it will always ensure that three replicas of that pods are running in the system. And if you delete any of the pod, it will recreate. If any of the pod gets failed, then also it will remove that failed pod and recreate a new pod. So that's what the job of the replica set. And along with it also help you to do the auto scaling. And let's say you have three pods. If you want to make five pods, you can increase the count of the pod as well. Demo of the replica set I have given in my previous video. The link is given below. You can check it out. Now there are some features which are not present in the replica set. One of the feature is rolling update of the version change. What are rolling update? It's the process of deploying new image to the pod without or with minimal downtime. Like the running pods, the current traffic into the system should not get affected. This is the mechanism what we call as a rolling update, and that video also I have given in the description. I have already prepared a video on rolling update. You can go through and understand what is rolling update. And similarly, when you perform the rolling update, you may require to go back to previous version if anything goes wrong. Even that option is not available in the replica set controller. And there are some of the deployment strategies. If you see my previous video, you will see I had explained you what is rolling update and all, what is rollout, rolling update and all, and different types of rolling update strategies what we have. This support is also not available in the replica set. So the reason Kubernetes have came up with another controller called deployment controller. Okay, I I will tell you like more detail about the deployment controller. What we do, we go to our demo section, we'll create one deployment controller, and we'll come back to slides again. So I have a Killer Coda session running here. Okay, I have this link of this example also I will give in the description. You can copy the content or you can create your own deployment also. Okay, what we do, we'll create a deployment file. Deployment.yaml file I will create. I already have it one. Deployment1.yaml. So if you see, the file content looks similar to replica set. Thing like kind previously it was a replica set. Now you can see it's a deployment, and total replicas we are creating from this using this deployment is 3 replicas we are creating. So before that, let's check whether we have any pods running. No. Do we have any replica set running? No. Do we kubectl get deploy command to check if there are any deployments are running? No. Okay, we apply now. Apply -f deployment one.yaml file. Now you see kubectl get pod, reports are running, and the beauty of the deployment controller is it automatically creates the replica set also. And actually, these pods are created by the replica set, which is created by the deployment. Okay, kubectl get replica set. I will give rs. You see, there is a replica set is also created here. kubectl get deployment. You see, there is a deployment. So what is happening whenever you create a deployment file, resource, deployment is a resource. Wherever you create a deployment resource, it will internally creates a replica set, and that replica set creates the pod. So whatever the functionality of replica set, all the functionalities are by default present in the deployment. Okay, and deployment is having some of the additional feature as well. Okay, and you can see the naming convention if you want to identify in the future like how you can relate this pod belongs to this deployment. You see the name of the deployment is nginx deployment. And what is the name of the replica set is created? Nginx deployment, then a random screen, a random number. What is the name of the pod? Get pod. Nginx deployment, name of the deployment. Then if you see this is the name of the replica set, then there is a random string. Okay. So what are the extra features what the deployment is supporting? One is a rolling update. Okay. Rolling update video I have already provided in details. Okay, you can check it out. Okay, and roll back to previous stable version. That is the beauty of the deployment controller. Like if you have upgraded a pod with particular version, and let's say for some reason you want to roll back to previous version, this deployment controller maintains that history. You can easily go back to, in one click you can go back to the previous image. Okay, version history tracking management, automated scaling and scaling down, scaling up and scaling down, and automatically creation of replica set, and several other features like max search, max unavailable, custom deployment strategies, which you understand in depth while we study rolling updates. So, okay, all good so far, but there is something which we need to observe here. The names of these pods. Okay, if you see, each pod has unique string appended at the end. Correct? Unique string appended at the end. For example, I have 3 pods here. Let me delete one pod. Delete pod. Let me delete this pod. Copy. Paste. Okay, so I have deleted this pod, and now if you see, pod got deleted. If I do get pod again, you see the new pod is created. That pod which I deleted, the ending with LR is gone. 85 a new pod came up. Okay, but this pod is also having a unique string which is not matching with the previous string. Why? The reason, because deployment controller works only with stateless applications. Okay, only works with only stateless application, and if you want to run stateful application, then we need another controller which is provided by the Kubernetes, and both are required, depends upon your use cases. So I will prepare a next video, and in that next video, first I will explain you the difference between the stateless application and stateful application. Then I will tell you why deployment cannot be used for stateful application. Then we can discuss the controller used for stateful application. Okay, so that's all in this video. I hope you like it. Please like, subscribe, and comment if you have any doubt. Thank you very much.